This time I'm going to increase the number of hosts to 25. And so I want to create some subnets from network address 172.16.1.0, my class B address. So each will have 25 host addresses for these following user VLANs. And these are 4 VLANs. Each of them have a variety of desktop, laptops, maybe mobile access devices, a variety of things. And so they're user VLANs. And there's my topology, and there's 4 VLANs. So that means 4 subnets. There's a layer 2 switch. So I want to calculate the subnet mask required for 25 hosts per subnet. So I want to know what that subnet mask is to give me those 25 hosts. So we'll go to my subnetting table, get to 14 is not enough, so I have to go to 30 hosts. And what's 30 hosts? Go over here, and that's a /27 mask. It's 5 host bits. I'm going to be doing a /27 mask for this example. And /27 means there's 5 host bit here in red, and 3, whatever's left, 3, is available for subnet bits. So that's the host portion there, and that'll give me 30 host address. And the /27, that's the subnet mask length. So the number of host calculations starting from the right, 5 bits assigned here from the right. So from the right I'm going to add up the first 5 bits, the values for each bit position. And that'll give me 31, 16, 8, 4, 2, and 1. I'm going to add the number 0, and that gives me 32 addresses, possible addresses. However, there has to be 2 subtracted for the network and broadcast address that are not assignable. And so that gives me the 30 host addresses, so that'll work for our example. It's a little bit more than the 25, but there's certainly nothing wrong with that. So we'll calculate the number of subnets. So in this case, I know I've got a /27 mask. That's 3 subnet bits that are available. There's 8 bits per octet. So the 3 subnet bits gives me a total of 8 subnets available. So those 3 left bits, I'm going to subnet those. So 8 different subnets, or VLANs in this case. We're creating 8 from this 172.16.1.0 class B address with 30 hosts per subnet or per VLAN. And now I need to identify the subnet multiple to assign to subnets. The multiple is something that's required to do the calculation when we start specifying each subnet and how we're going to assign addressing. So in this case, there's 5 bits for hosts, and these 3 here for subnets. So starting at bit position 6, that value would be 32. That's bit position 6. So just quick reference there. That's the value of it. And so there's 8 subnets available. 0, 32, 64, 96. I'm just adding 32 because it's a multiple. So there's 8 subnets from 0 right through to 224. That's where I'm getting the 8 subnet available to, or network addresses. They're synonymous. And step 4, calculate the network address, broadcast address, and host address range per subnet. So here I'm going to start again with the 0 subnet. So 172.16.1.0/27 is the 0 subnet, and there's 30 hosts within that subnet that are assignable. Multiple is 32, and I'm going to get 8 subnets. So in this case I've got the 4 user VLANs, 9 through 12. So 9 is going to get the 0 subnet, 10 is going to get the 32 subnet, and 11 will get the 64 subnet, and 12 will get 96 subnet. The same process. You start with 0, and then you add 1 through 30, and that's the host range, and then 31, and then so on for each one. All 4 subnets are accounted for. So you've got the host IP address range and network and broadcast address, and that's all you need to define a subnet. And here's just a picture of how I'm going to assign the addresses. And these are the network addresses, subnetted network addresses, if you like. 0, 32, 64, and 96. That's all easy enough, and there's room for adding 4 more because I've got 8 subnets available